Have you ever been puzzled by a piece of code that just doesn't seem to make sense? If you've ever wondered why r-2 isn't equivalent to -2r, you're in the right place. Today, we're diving into this intriguing question. I totally get it. It can be incredibly frustrating when you think you understand something, only to find out that it behaves differently than expected. You're not alone in this confusion. Many programmers have faced similar issues. Let's set the stage. A user recently asked, why isn't r-2 equivalent to -2r? They provided a code snippet that outputs an unexpected result. Sound familiar? If you've encountered this, let's explore it together. So what's happening here? When you access r-2, you're trying to access an index that is out of range, which leads to undefined behavior. On the other hand, -2r is a valid expression due to how C++ interprets array indexing. Let's break this down. And stick around. At the end of this video, I'll share a quick tip that will help you avoid similar pitfalls in the future. To understand why r-2 and -2r behave differently, let's first clarify what these expressions mean in C++. The user should know that array indexing in C++ allows for both notations, but they are not equivalent. The expression r-2 attempts to access the element at index -2. This is out of bounds for the array defined with 3 elements. Therefore, it leads to undefined behavior. On the other hand, the expression -2ar is actually a valid way to access the array. In C++, the syntax AB is equivalent to 2a plus b, so -2r translates to r-2, which points to the memory location 2 integers before the start of the array. This means that -2ar retrieves whatever value is stored at that memory location. In this case, it happens to return -30, which is the value at that location, but this is also considered undefined behavior. In summary, while both expressions are syntactically valid, r-2 leads to an out-of-bounds access, while -2r accesses a memory location that may contain unexpected values. The user should always ensure they are accessing valid indices to avoid undefined behavior. Fun fact, in C++, array indexing can be a bit like a magic trick. Sometimes what you see isn't what you get. Always be cautious with your indices. Now, let's look at the answers provided by other users. This user explains that the difference between r-2 and -2r comes down to operator precedence in C++. The subscript operator has higher precedence than the unary minus operator. So when you write r-2, the compiler first evaluates r and then applies the negative sign, leading to undefined behavior. In contrast, with -2r, the compiler evaluates 2r first, which is valid and results in -30. They also note that you can write it as -2r to achieve the same result. Here's a quick tip. Always ensure your indices are within the valid range of your array. This simple habit can save you from unexpected behaviors and bugs. And there you have it. Now you understand why r2 isn't equivalent to -2r. Remember, understanding the fundamentals of array indexing can save you a lot of headaches. If you found this video helpful, don't forget to subscribe for more coding insights.